Hey guys, I wanted to take a second and just go over a few things with you for those of you, especially those of you who are reviewing asynchronously, just so that you have kind of some questions to answer and a resource, questions answered and a resource for you to go back and touch base on. Okay, so the first thing I wanted to start on is just this properties checklist. So what I want you to notice is that, I don't know about your teachers, I have driven home so much these 5 properties of parallelograms, right? So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Okay, so those are those special 5 properties. And then remember, we talked about the rectangles, rhombus, and square. They are all parallelograms. So they should have all of the properties of a parallelogram. And then you can see that they have some of their own properties. So remember, a rectangle, its properties are that its diagonals are congruent. And then by definition, it has all right angles. A rhombus has perpendicular diagonals. Its diagonals bisect the angles. And then again, by definition, it has all congruent sides. And then remember, we talked about a square is a rectangle and a rhombus. Remember, it's a square because it has the 4 right angles. A square is a rhombus because it has the 4 congruent sides. So that means it has the properties of a rhombus and the other property of a rectangle. So the square has all the properties. Okay, so everything that's true about a rhombus is true about a square. Everything that's true about a rectangle is true about a square. Okay, now remember these over here, this was our parallelogram kind of set. And then over here, we have these quadrilaterals that are not parallelograms, but they do share a few similar traits. So a trapezoid. So a trapezoid has 1 pair of parallel sides. Remember, these are the bases, right? I'm going to kind of have this trapezoid over here. So we have our bases are the parallel sides. Then we have opposite sides are congruent. Well, again, that doesn't happen in most trapezoids, but it does happen in an isosceles trapezoid. Remember, in an isosceles trapezoid, we see that the legs are congruent, and so that's that opposite pair of congruent legs, or opposite pair of congruent sides. And then we have 2 pairs of consecutive angles. So in a parallelogram, every set of consecutive angles is supplementary. In a trapezoid, we have this pair along each leg. So we have this pair along this leg, and we have this pair along this leg. Those are the supplementary consecutive angles. These would not be supplementary going along the base. Okay, so it's just the pair along each leg. Those are supplementary. Okay, and then again, diagonals are congruent, but again, only in an isosceles trapezoid. So the thing to remember, isosceles trapezoid has congruent diagonals and it has those congruent opposite sides. And remember, it does have congruent base angles. Now, it's not opposite, opposite angles that are congruent, but we have those. If it's a trapezoid, an isosceles trapezoid, remember, we have this pair of base angles that's a congruent, and this pair up there of base angles that are congruent. Okay, and then a kite. So a kite has 1 pair of opposite angles congruent. So remember, I'll give you a little picture of a kite. So remember, this is congruent to this one, and this one is congruent to this one. So remember that the congruent opposite angles are the ones in between the non-congruent sides. So those are the congruent opposite angles. And then the other thing that we know about a kite is that the diagonals bisect the angles, but again, only the angles that are between the congruent sides. And we also know that diagonals are perpendicular. Okay, so opposite angles are the ones not between the congruent sides. My bisected angles are the ones that are between the congruent sides. And then again, we would have those perpendicular diagonals just like a rhombus. Okay, so that's this is what you need to make sure you know. If you know these properties, then you should be able to do just about any problem on the test. Okay, so now let's jump in over here and let's talk a little bit about the review. So the first thing I want to point out is we've got this angles of polygons. So first I want to remind you of all the different formulas. So remember the sum of the interior angles. The way that we calculated this is we said how many triangles are there, And remember, there were always n minus 2 triangles, n being the number of sides, times 180. And that's how we found the sum of the interior angles, because we took the number of triangles and then we know that there are 180 degrees in each triangle. And then so that gave me the sum of the interior angles of any polygon. Remember, n being the number of sides. Okay, so each interior angle, well, again, that can only happen if it's a regular polygon. Remember, regular means that all sides and all angles are congruent. So each interior angle, we're going to take that sum that we found in A, n minus 2 times 180, and this time we are going to divide it by n, because n is the number of sides, but it's also the number of angles. Okay, now remember, the sum of our exterior angles, this is always our favorite because there's no work required. Doesn't matter if there are 3 sides or there are 103 sides. The sum of the exterior angles is always, so remember, 360, always. That never changes. Okay, and then D, that each exterior, we're going to take that sum of the exterior and we're going to divide it by n. Okay, so let's look at a couple of problems. I am going to jump over here and let's do this nonagon problem. Okay, so remember, you do need to know the names of the sides. So you will be just asked what's the sum of the angles of a decagon, and you need to know how many sides are in a decagon. So in a nonagon, there are 9 sides. So that means this right here is my n. So now I'm going to plug it into my formula. So I have 9 minus 2 times 180. That's 7 times 180, or 1260. All right, so that's the sum. 1260 is the sum of the angles. Now I want to find each interior angle. Now I don't have to do that n minus 2 times 180 again because I already know what that is. So I'm going to just take the 1260 sum divided by 9, because again, there are 9 angles if there are 9 sides, and that is 140 degrees. Our favorite one always, no work required, 360 degrees is the sum of the exterior angles. And then I'll take that 360 divided by 9, and I get 40 degrees for each exterior angle. And then remember, you can always kind of check because each interior and each exterior should always be supplementary. Okay, so these are always supplementary. Okay, now moving down to these problems here, they are just taking kind of what we did at the top and taking it one step further. Okay, I'm going to start with 7 and 8. So remember, we know that the sum of the exterior angles is always 360. So what does sum mean? Sum means that you're adding the terms up. Okay, so if I add these terms up, I could write out 2x plus x minus 1 plus 79 plus x plus 10 is equal to 360. Okay, so it doesn't matter if it's a quadrilateral, if it's a pentagon, if it is a, nonagon or whatever, you're going to add up the angles on the exterior, and it's going to equal that angle, the sum of the angles on the exterior, which is always 360. So we combine our like terms, 2x plus x gives me 4x, negative 1 plus 79 gives me 78, plus 10 is plus 88. Is equal to 360. When we subtract that, 4x is equal to 272, and we divide it all by 4, so x is equal to 68. Okay, so remember here, you're going to, oops, sorry, I can't write today, add up to 360. Okay, so that's the easy one, is the exterior, because they always add up to the same thing. Now, these are a little trickier because polygons, the interior angles of a polygon don't always add up to the same thing. So the first step we have to do is calculate the sum of interior angles. Okay, so let's look at this pentagon one. Okay, so the first thing that I need to do is figure out what the sum of the interior angles is. So we know pentagons have 5 sides. So 5 minus 2 times 180. So that's 3 times 180, or 540 degrees. So now we know that the sum of all of these angles is equal to 540. Okay, so I have 2x plus 142 plus 2x plus 3x plus 14 plus 3x plus 14. Okay, and then we would add up all of our like terms here. We get 10x plus 170 is equal to 540, and you can solve from here. Okay, but oh, sorry, I forgot to say that. So first, calculate the sum of the interior angles, and then second, add up angles to equal the sum. Oops, too many bumps, but okay. Let's look at the next one. Okay, so now a lot of these, I'm not going to be able to go through all of them, but what I want you to pay attention to is when you're looking at parallelograms, you're going back to those 5 properties. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals are bisected, okay? So all of those 5 properties you're going to have to apply here. So let's look at this first one. So for instance, it's asking me what AB is. Okay, so this is the length of a side. Well, what do I notice down here? This one is 12. So CD and AB have to be congruent because this is a parallelogram. So then AB is 12. Okay, and then remember, opposite angles are congruent. So if I'm looking for DCB, I don't have to look very hard. It is just straight across. So this would be 115 degrees. Okay, then similarly, we know we're looking for ADC, and we know that consecutive angles are supplementary. So we could take 180 minus 115, and we get, what is that, 65. Sorry, so this is that right? Yeah, 65. 65 degrees. Okay, so paying attention to all those properties. So opposite angles, consecutive angles. I'll put my 65 here. If this is 18, then what is AD? Also 18. Okay, so we talked about opposite angles. We talked about consecutive angles. We talked about opposite sides. So let's go over here because this one's going to kind of give us another property to look at. As we see over here, we have the diagonals drawn in. And remember, diagonals bisect each other. So what that means is that they are cut into congruent parts. So if PS, if we want to know what PU is, what do you know what PS is? So this one's 16. If we know that this is 12, then that's 12. Okay, so what was it? PU was 16, and let's see, PT was 12. Okay, and then we see this term with X is linked to a side, right? And we know opposite sides are congruent, so we could set those equal. Okay, so remember that sometimes you're going to just be given numbers and you can just write the numbers. Sometimes you're going to be given expressions, so we have to solve an equation. We know that this 3x has to be the same as that 15, so we can just say 3x is equal to 15, so x is equal to 5. Okay, so right through here, you're going to see some of those ones where you're going to have to write equations. The ideas are no different, right? These are talking about the diagonals. So these guys are congruent and these guys are congruent. And remember, congruent things can be set equal. Okay, same thing over here. You look and say, okay, are we talking about opposite angles or are we looking at consecutive angles? Well, we see consecutive angles that are supplementary here would give me 2 variables if I tried to do that. But here, I see that they're opposite each other. So I know opposite angles are congruent. And remember, when things are congruent, their measures are equal. So I could set up 12x plus 72 is equal to 25x plus 20 and solve that one. And then I would similarly have an equation to set these two equal to each other. Okay, rectangle. So we've already talked about the properties of a rectangle. Remember that the diagonals are congruent and our angles are right angles. So here, when it gives you FK, we know that this is 32. Well, and because it's a parallelogram, we know this part over here has to be 32. So then when it's trying to ask us what EG is, we know that we would be looking at this diagonal. Since it's a rectangle, they should be equal. So it would be the same. It would be 64. Okay, over here we talk about HEK and KEF. Well, what do we know about all of our angles, right? They're all right angles. And what's the measure of a right angle? It's 90 degrees. So these two angles in the side of angle E would end up adding up to 90 degrees. Okay, you have another one that's asking you about the diagonals. So again, we know the diagonals are congruent. So if things are congruent, we can set their measures equal. So set these equal and you're going to write an equation. Okay, let's go back and think about some of our properties of a rhombus. Well, we know, boom, 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 all those sides will be congruent. We know that the diagonals are perpendicular. Okay, and then we look and see kind of the different parts that it gives us. So let's see, it tells us that this is 15. It tells us EB is 9. It tells us ABD. I don't really have room to write it, but that angle right there is 55 degrees. Okay, so when it's asking you for AE, now guys, this is something that you're going to see a lot on rhombuses or rhombi and kites, is that when you're looking for a missing part, and what we see is that these are all little right triangles. So here's a right triangle, here's a right triangle, here's a right triangle, here's a right triangle. So you're going to go back to that everybody's favorite right triangle theorem, a squared plus b squared equals c squared. And then remember, on the kite and on the rhombus, the sides are going to be c, okay? Because see, they are opposite that 90-degree angle. So that's how you're going to plug in what you have. You have your C, you have your A, so you'll be solving for B. Okay, so if we know that AB is 15, then what's AD? Well, what do we know about a rhombus? All those sides are congruent, so we would know that that's 15. Okay, then AEB, what do we know right there? You see my little boxes. What is that little box? When they are perpendicular, what does that make this angle measure? And then lastly, we talk about CBD. Well, the other property that we haven't really dove into with rhombi is that the diagonals bisect the angles. So if this is 55, then this also has to be 55 degrees. Okay, mid segments. Okay, I'm going to write the formula for you. So remember, it is 1/2 base 1 plus base 2. Now, guys, this works. The formula works. See, like here, we're given the top base and the bottom base. So we would just plug it in here and solve for the mid segment. Now here, we're given the mid segment and the base. So we're going to have to let our other base be a variable and solve that equation. So if we know, if you say that, sorry, let me write this, the mid segment, right? So if we know the mid segment is equal to that, here's my mid segment. So I can say that the mid segment is equal to 1/2. I don't know what QR is. That's X plus UT is 12. And then I can just solve this equation. Okay, let's think about trapezoids right here. We see that this is an isosceles trapezoid. It's asking me for angle Z. And remember, in all trapezoids along each leg, so right here and then right here is a supplementary pair. Remember, because they're same side interior angles. So we can just take 180 and we can subtract the 112. All right, over here, we talk about, again, isosceles trapezoids. So what that tells me is that it tells me that these sides are congruent. That's how we know it's isosceles. And then it says which angle is congruent to BCD, BCD. Okay, so remember we have congruent base angles here, and we have congruent base angles there. So you tell me which one is congruent to make sure you name it properly. And then which side is parallel? Well, if these are the legs, remember the legs are the non-parallel sides. So these are our parallel sides. And then what segment is congruent to AC? Remember, diagonals are congruent here. So this diagonal is congruent to that diagonal. All right, some kites. Okay, I talked a little bit about this one a second ago. Remember, we know the diagonals in a kite are perpendicular, so that gives us those right angles. We're looking over here for C, so we'll use that C squared is equal to A squared plus B squared. We know our A and B, and you can plug in and solve. Okay, now when we look at a kite and we're looking at the angles, so we can see that these are the congruent sides and these are the other pair of congruent sides. And remember, we know that the angles that are in between the non-congruent sides, these are the angles here that are congruent. Okay, so how are we going to solve this one? Well, we know that in all quadrilaterals, there are 360 degrees. So we know that we can take away take those away from 360. So when I do that and I take away my 360, I've got 360, and I'm going to subtract 49. First I'll do that. So I get 1, that's 5, 3, 11. Then I'm going to subtract 67. That'd be 0. So that is, what is that? 4 and 244. Okay, so then that's 244 degrees left, and it is split between these two angles. So we can take 244 and divide it by 2 to get 122 degrees. So they would each be 122 degrees. Okay, then again, this one is just like this one. We have those perpendicular diagonals, so we can use Pythagorean theorem to find our missing side. All right, and our last ones, remember in isosceles trapezoids, we know that the legs are congruent, and then we know that the diagonals are congruent. So here you're being given a diagonal, so you know what the other diagonal is. And same thing here, you're given the same diagonals, or sorry, it's a different picture, but you're given the diagonals, but you're given expressions this time. If we know the diagonals are congruent, you can set the measures equal. Okay, and then over here, we're talking about the legs. So if this is isosceles, remember we know that the legs are congruent and we know the diagonals are congruent. Here we're talking about the legs. Same thing over here. So legs are congruent. So if this is 8, then this is 8. Okay, so BC would be 8. And then over here, you're going to have to write an equation because you have AD and you have BC and we have their measures. So again, congruent segments means their measures are equal, and we can just solve the equation like that. All right, hope this was helpful. Again, most teachers are having office hours on Friday, so check in if you need help.